Hey, everybody. Thank you for coming out to join us this afternoon. I want to start by thanking our co-sponsor, the new Institute for Climate and Sustainable Growth. We're pleased to host this with them and proud to welcome Dan Kammen, our guest speaker. Some of you who were here at the Kreisman Symposium last year might remember that Dan Kammen came and was a panelist there that day. And his talk was so great and interesting that we said we have to bring this person back and give him the spotlight, let him have his own session to talk to us. So I'm so pleased that he was willing to come back and do that for us. Dan's many affiliations you can see on this slide, so I don't have to read them all to you, but there's even more which he'll tell you about that are not listed here. I can tell you a fact that will surely embarrass virtually everyone in the room, which is that Dan has published more than 450 papers. And his research, he's currently focused on decarbonization of power systems around the world, energy access and social justice, material science for low carbon economies, big data approaches to clean transportation, and on the electrification of health facilities across Africa, to name a few topics. In addition to his academic affiliations, Dan has founded or is on the board of over 10 different companies. He's served on many different governing boards. He's served as a senior advisor for energy and innovation at the U.S. Agency for International Development and several other institutions that may or may no longer exist. He was educated at Cornell and Harvard. He spent time at Berkeley, where I will note his most important accomplishment, which was co-authoring a paper with our president, Paul Alivisatos. And so he's a co-author, greatly beloved here. And I could go on and say more about him. He was elected to the American Academy of Arts and Sciences in the year 2020. But let me stop from using all of our time to list his accolades and give the floor back to Dan to talk to us.
Thank you so much. Well, thank you so much for having me back. That's what I really appreciate. I learned a lot in that discussion, and I'll try to echo a couple of the themes that came up there. And just one kind of point of your style. I have physicist culture, which means that if someone has a question, it's not just a soliloquy. I urge people just to jump in and ask it en route, or do you like to hold it? It's totally up to you guys. I encourage jumping in.
Up to you. So okay, we'll take your ground rules.
So please jump in, comment, dispute, question as we go. We will still do Q&A at the end, but I'd love it if we, especially things that I will do my best, since we said we have extra time, I'll do my best to be extra annoying. So I'll try to highlight some of the challenges that I see going on. And so, did I press them? Oh, okay, get it. Yes, okay. And so my laboratory at Berkeley is Rail. And so all of the papers, publications, and non-academic stuff was there. You actually need to Google my name and Berkeley or Rail or whatever else. If you just do Rail, you may get the Raelians that cloned a human 20 years ago in Florida and have not been heard from since. And since I don't use any certain site anymore, this is the other one. So feel free to, and we try to do like one, are they called tweets? I don't know what they're called here. Non-tweets, I don't know what they are, but we try to do one a day about stuff that our lab is doing. So feel free to jump into that. And as was highlighted, I'm doing it wrong. I'm just going to use these. Okay, so Rail is my laboratory at Berkeley, but I am in the process of making a transition to Johns Hopkins. So as a physicist, I have this complicated middle ground. And after 25 years of loving it at Berkeley and still loving it at Berkeley, I'll get into a couple of the reasons why I'm making this move, and hopefully some of them open doors to some collaborations and some discussions. So what I'm hoping to talk about is a little bit of where I currently see justice, equity, DEI, all these words that are not recognized in DC, currently sitting on the landscape of what is not just a climate imperative, but is a locally actionable imperative. And so when I started working on this back when dinosaurs roamed the earth, essentially none of our clean energy systems were economic. And so we made lots and lots of discussion points about when they're economically or in what special cases. That has changed. And so I am very glad I entered this whole field as a physicist. I think there's still a big role, but we are making finally satisfactory progress on the hardware side, on the science and innovation side of climate and sustainable systems. We are in a disaster when it comes to the social science side of the equation. And so almost every undergraduate asked me, as I suspect asked many of you, a question that comes out something like, I'm new to the area and I'm interested, what do you think I should study? And what I say is you should study whatever you like most or you feel most engaged with, because unfortunately we need all of these desperately, and the traditional perspective, at least in the tribe that I come from, physical scientists, that is not our number one need. We still need massive innovations, but we are critically in need of the non-STEM aspects of the story. And I don't think you can solve the climate problem without both pieces. And I'll make the stronger claim in a second, and that is that I don't think you can solve climate without centering, not just whining about justice, nor can you solve justice without recognizing that climate is central. And I'm going to hopefully that message is really the key one going forward to talk. And despite what certain individuals who are not elected to any job in DC say, I actually think that by doing that, you do what civilizations, what settlements, urban and otherwise need, which is you need to operationalize some version of empathy. And I think actually by doing this, you actually get that equation pretty centered. And so I'm doing this wrong. Is it just timing out, or am I just being too slow? I talk too much and click too little. And so it is a grim world out there. I just moved to DC. I thought I was moving there under Harris Walt's administration. I found out, no, I'm not. And so, you know, the Department of Energy and now the EPA are all engaged in some effort just described as energy dominance. Doge seems to be following the Kristallnacht model almost to a T. And so those of you who are not historians of Nazi Germany should go read some of that, because our lack of protests are part of the story. And these unprecedented sets of cuts in services are not just ugly and job removing, and our inability to respond to what's taking place in Myanmar and is taking place in lots of places. But I do think that the last point is unfortunately the most important one, and that is, as ugly or not, if you're aligned with what's going on in the White House, that's your own view, but self-censorship is worse than censorship by others. And we are seeing massive self-censorship in everything from what we say to what we work on to how we frame things. That is a massive mistake. And so, you know, we are seeing a new world order and everyone is adjusting to it in ways large and small. Hopefully this talk will be, after my depressing 49 minutes, I'll be optimistic for 6. And so the climate science story is that our emissions are the black line over here, rising emissions, and that depending how you parse the language of the various climate treaties, we are almost certainly in this zone at best, meaning roughly 3 degrees of warming, plus or minus, whatever. There's language on the paper that would say different if you look at only the short-term emissions or those that don't involve methane. There's a whole really interesting physical science world. This is my IPCC background. Recognizing that the climate science says that we need to go carbon negative by mid-century. That does not necessarily mean carbon capture from industrial plants. That might be actually what I prefer, reinvesting in nature, reinvesting in mangrove swamps, in forests, et cetera. But there needs to be a carbon negative, and all of these pathways are not even recognizing we need a sign change, not just percentage changes in this overall picture. And that's what the science community will tell your new undergraduate majors, what we're telling our undergraduate majors. The other side of the story, however, is that Another process, equally flawed, is focused around the 17 United Nations Sustainable Development Goals, whether you think they're an ideal set of goals or not, whether you remember what the 169 or 174 subcategories are. I personally start with SDG 7 that says that of the roughly 800 million people on the planet who do not have access to electricity, the goal for 2030 is to make that number 0. And I work closely, as you heard in the introduction, on both the gender, the sanitation, and then number 3, the health. And I'll try to end the talk with more than 30 seconds on what is the main part of my own research agenda today, but I'm going to get there slowly. And that's on the energy health nexus. And as bad as that climate story is, this story is worse. So when you look at, this is the latest UN's own assessment of progress towards these goals, the number of those goals that have red bars, and it's complicated because each of these 17 has from 5 to 15 subcategories. So there's a bit of a complicated math, but the amount of stagnation or regression on this chart for our 2030 goals is massive. And I think that if you don't talk about climate in this context, and these goals really do reflect social, economic, gender, and racial justice. They're not perfect by any means, but it is explicitly in all of them, almost all of them. There's a couple that are like basically all of them. And so we are making negative progress on the climate goal, and we're making negative progress on these SDGs. And that is a recipe for disaster. So as a physicist, not as an economist, where I'm going to end up, my comments are adding the constraint of we not only need to meet our climate goals, we need to meet these goals. An economist of some flavors would say you're taking a hard problem and making it harder, adding a constraint, therefore you're making this job hard. I think the opposite is true. I think our data now indicates that by adding the constraint of meeting these social and environmental goals, we make the climate goal easier. And that's my core kind of finding. I'll try to illustrate that in the data, but because that's a pretty big story, it's going to be more hand-waving and rhetoric than convincing you that I have enough. I think the theory's on my side, but you can judge by the data as we go. But it's a really grim picture, and the justice piece is that, you know, I don't want to assume anything about anyone's own socioeconomic system in the room, but it's highly likely that no matter how you feel about your own situation relative to world's billionaires or trillionaires, that almost everyone here is living certainly in the top 10%, quite a few living here. But what that says is the affluent 10% of the world population contribute more than half of the emissions, and the poorest 50% are under 10% of the emissions. That is a striking picture, and what it means, and I'll try to illustrate that very soon in the next 4 or 5 minutes. What that says is that as grim as things seem to be in Washington, D.C., and fairly grim in Rome with Meloni, and until the arrest of Bolsonaro looking like he's going to win in Brazil, we are in a bad situation on both fronts, so we need to really change that equation dramatically. So, clearly not good. And so if we look at what the UN, the Sustainable Development, I'll say differently, if we look at what the Intergovernmental Panel on Climate Change says we need to be achieving, that 2% or less degrees warming, that was revised after the Paris climate meeting, COP21, to be 1.5 is the new goal. So we're revising our goals to be more stringent when the world's going the opposite direction. And they're not all exactly the same, but more or less hitting 1.5, of which almost no one, I would argue, nobody thinks we're on a pace for. Very few think we're on a pace for 2 degrees. It's more or less a factor of 2 worse. If we only achieve 2, and right now the world, as I highlighted, is on a path for 3, and there's someone in Washington, D.C. who thinks the path the world should be on a pace for, it doesn't matter. Just to highlight that in kind of more real world terms, there's a May Day 2 years ago in New York City. 2 days later, from fires, not in the US, in Canada, it looked like this. And that is worse than the science fiction authors think for 2049, right? So that you can see that's not too data rich, but I thought it was a pretty good movie, and they thought the world would be better in 2049 with the garlic and the slugs that the big guy was eating in his home in the beginning. So it is a bad picture. We at Berkeley are proud of the work on this, and so I got this wonderful plaque for being part of the Nobel Prize team. And because at Berkeley, the most valued thing, and Michael Watts can highlight, it's actually not the money or the plaque or the medal, it's actually the parking space that you get. And there's NL parking spaces are all over campus, but back then there were not EVs in large number, and so Berkeley debated, and the very wise master leader of our infrastructure said, well, we're going to give the 4 Berkeley people their due reward. But of course, it was for Nobel laureate bicycle parking. And I obscured the fine print. It says this is not reserved even for those Nobel laureates. So Berkeley has its just to put this version of why I'm focusing on this 2030 goal in a little more context. If we believe, and I think this one is not debatable, that we are not going to meet our climate or our energy access or health access goals purely with public sector funding, that there will have to be a big dose of private sector actively wanting to do it for a variety of reasons. I don't think that's in debate. But one version of that story is that if we don't find a way to make not just the climate goal, but all of those sustainable development goals, things that the private sector actively wants to invest in, we have zero chance to make progress on this goal. We'll have nice programs, we hope we'll have this or that, people will write nice papers, they'll do PowerPoints, but we have given up. And so thinking about how to shift this into the private sector world, where I believe this 2030 goal less than 5 years away is so critical, even though some of those SDGs are a bit hard to highlight. So one aspect of that story under prior US administration was the fact that there was a very clever PR team that found a city. I have now found it on the map. I had never heard of it. I have never been to it. Michael, if you've been there, you let me know. They found a small town in California called Sunnylands. I have yet to go there. And in Sunnylands, ex-President Biden and President Xi then had the Sunnylands Agreement, which they signed, and that said that the US and China should each work to triple the amount of renewable energy in use worldwide by 2030, and should partner in emerging economies to make that happen in those economies as well. So just to highlight where that's at, with a American and a Chinese graduate student, we kind of worked up the numbers. They're pretty simple. And you'll hear from proponents of renewables, myself included, that we are finally on an impressive growth path for clean energy. Solar and wind and battery prices have fallen dramatically. Solar and battery prices have fallen by 90% in the past decade, and wind prices by 60%. That is remarkable. More than 85% of all new demand for energy worldwide is for clean energy. That makes a wonderful exponential growth curve here. And what it means is that even with this remarkable step forward, despite the bad news politically around us, what it means is that we will miss our 2030 target for clean energy by an amount that green bar is almost exactly equal to the amount deployed worldwide today. So it's not, unfortunately, very hard math, but it's a scary equation. And the only country on pace to meet its clean energy goals is China. And there's a huge footnote on that. And so what this means overall, China's on pace, the US not on pace, EU not on pace, Africa not on pace. And so what this means is that US policymaking under the prior administration is one that we use setting goals to spur action, spur industry, bring in the private sector. China approaches it somewhat differently. They set goals they think are achievable. China is going to achieve, if their pace continues, that tripling of renewables by 2030, but they are also the largest builder of coal plants. And the goal is not just to grow the amount of clean energy, the goal is to replace. And so I've now given you three very depressing pieces of information, right? The climate story is bad, the SDG story is bad, and even the only place on pace to make this goal is also, I would argue, throwing away this benefit by not actually replacing it, by adding it. So, if you're not thoroughly depressed, then you obviously had a drink before you came. On the other part of the story, as I work closely with a big consortium of partners in China, we have modeling teams I'll highlight in a second, but we need China as much as they need us, and this current tariff war is the exact opposite of what we need, I think very clearly. And here's an example in the energy space. So here is one of the companies that borrowed a business model from a Tel Aviv to San Francisco to Copenhagen startup called Better Place. And that was that as electric vehicles rise, why don't you buy the vehicle, but the battery is owned by a third party? So Better Place is you were to drive in and you swap your battery out. Here is NIO. They have 2,000 battery swapping stations in China. You drive your car to here, you get out of your car, it backs itself in. 3 minutes later, you can see these things, you have a new battery in, and if new battery technology comes along, there is some real logic to doing this. I am shocked that they are doing this model. I didn't think it would work, but then not only the NIO people, but many others in China think it will work. I'm more in this category. This is another Chinese company, CATL, saying you can add 400 kilometers of range in a 10-minute recharge. So there are some remarkable things happening for which we are way behind, and I'll try to highlight where some of those play in a bit. In my own case, and I think it's just a huge benefit of being in the Berkeley, Silicon Valley, California ecosystem, as you highlighted, I've helped to form or joined a bunch of really interesting companies, some of which are kind of classic. We've got companies like Enphase that make microinverters, meaning each solar panel has its own inverter on the back, and there are some huge data science advantages. I'm going to come back and highlight Pear City in a bit. It's now a Shenzhen-based company. Grid Alternatives, arguably the #1 energy justice, was originally an NGO, now a company in the United States. Virunga Power in the Congo, Energy Peace Partners. We have a product which is basically a credit for installing clean energy in conflict zones. Alpha Ring is a fusion company, and I'll end with it's not a joke, I'll with my fusion comment in a bit. And then I get to work with a whole bunch of nonprofits that some of which flow back and forth, but also are engaged in the space. And what I'll highlight in the beginning and try to illustrate where justice is needed in this process is we work officially with a whole range of governments. Some are somewhat easy to work with, some not so easy to work with. But in each case where we build open source models of the power sector today, we only do so when in country we have a university or a think tank partner, and we have an official government partner. Whether they share data fully or not is a different story. I was told never to do math in public, and so I won't. But this modeling framework is pretty straightforward for the electrical engineers in the room. We just minimize the total cost of the capital for new projects, whether it's energy efficiency or power generation or building transmission lines. There's operational cost, buying fuel, doing various things. And then there's the amount of reserve margin, the amount of energy that you have available to pull in. We analyze big and large countries in terms of their mixtures of doing so. We started in the Western United States, in the Socialist Republic of California. And we're working on all of these actively right now. And I won't do the electrical engineering version because while it's what I probably spend a third of my time on, we basically analyze situations. This is a picture of 2050, engineer or not in the room. The black line is the forecast demand, and you can imagine there's lots of uncertainty about what the demand is. This is 2 days each month, just stitched together, and the colors are supposed to be illustrative. Light blue is wind, yellow is solar. We have hydropower. We have tiny bit of nuclear in here, and these negative going spikes are energy that goes into storage, whether it's batteries or moving rock uphill or taking dams and no longer generating power just to feed into the market, but making the whole dam become a battery. So we just use the dam to load follow. So the total integrated area under these spikes is equal to the area that you see that power coming out, except for the round trip losses. And so we build pictures like this and work really closely with governments. We have a big team working in Japan, which is undergoing this ongoing debate. Do they restart all their nuclear? Do they not? Kenya is a wonderful case because it has currently the world's cheapest geothermal. The largest geothermal plant in the world is in California called the Geysers. Kenya has the most new geothermal coming online. And so we're working closely with the Kenyan government on should they max it out to power energy needs? Should they try to produce green hydrogen, if you're a green hydrogen fan, and sell it on the markets? And so a lot of work, but I'm not going to dwell on that, not that it's not critical, but largely these types of models are based on several processes of learning in the system. And I want to kind of highlight that because what I've left out of the narrative so far is how do you take this analytic story and build in justice into the process overall. So let me kind of recognize this is the backstory where we deploy a lot of this, but the basic picture is one that has multiple names: Moore's law, the so-called doubling of the computing power or the number of computing nodes per area on a chip. Gordon Moore said it. It's also called Swanson's law. There's a variety of versions. And what it says to an engineer is that every time that you double the amount of deployed technology, you get a reduction in cost, empirically observed. There are interesting views on how basic this rule is or not, but here's an example for solar. Going back to the 70s, you'll notice that time is neither the vertical nor the horizontal axis. This is the cost in log units, and this is the total amount of solar deployed. Time is just a stamp along this curve. It is in log space, so this is not a trivial dip. That's a pretty big, this had to do with a breakthrough in terms of how easily one could cut silicon wafers to make traditional solar cells. And what we have seen is that when I was in high school, solar was the most expensive. It is now the cheapest. Not on par with, but solar is now the cheapest form of power. It's kind of an amazing process. We see the exact same story in other fields. I think I'll put up the graph for energy storage in a bit. I'm not going to dwell on it. Mathematically, the cost at some future time relative to the cost at, say, now or sometime in the past is just related to that volume of sales to this negative exponent. That's the slope of this line. And so it's a really robust, powerful tool. All of our modeling of how we can get to various goals is based on some version of this picture here. And it's held for decades across many technologies, not just energy, big pens, computers, condoms, microwaves, they all follow this curve. We'll get to the end, which technologies don't follow this curve in a little bit. And because clean energy systems do not, in general, have a fuel cost, there are every now and then there's a fuel cost, but because you're investing in companies and people, one of the other benefits, it's not a implicit feature where clean energy is somehow better, but you're investing in companies and people, not in literally pouring some of your money down a well. And so the jobs benefits of this are dramatic. In California, we now have more people employed in solar than in all of the utilities combined. That's, of course, under threat with these tariffs. Same story is basically true in Denmark, and I'll come back to a couple versions of that in a bit. So what is it that one can rely on to go ahead? And just to put the scale of how dramatic this learning curve is, if we think not only about the technical learning curve, but also about the information, the data part of the learning curve, we get this interesting picture that if we go back to the Cray supercomputer in 1975, the old folks in the room remember, the young people will say, what blank is that? The Cray cost about $40 million for 160 megaflops. The iPhone today is $500. I know you guys generally don't buy the $500 version. That's 11 teraflops. The price has gone through a dramatic change as well. And so if you take the performance and the price benefits together, you don't get this learning curve I showed you here, but if you're taking performance times price, it's about 5 billion times better. So we have learned to do the computing, we have learned to do this process in a remarkably better way, and leveraging both of those features is something we have not brought to bear around this energy climate justice nexus that I'll highlight here. And so there's been the discussions, is Moore's law at an end? That's in Silicon Valley, you hear that every single day. This argues we're actually not doing that, and I'm just going to go back to Mark Twain. Reports of my death are greatly exaggerated, and we are seeing remarkable progress, and yet we're not leveraging it anywhere near the degree that we could to meet the climate goal or these SDGs. All that is really designed to be context for why this learning curve is so powerful. Here is the version for batteries, and I've divided this one up instead of one solar cell. The blue triangles are lithium-ion batteries that I almost am sure every single person in the room is carrying one or two of them right now. These other battery types for the material scientists, I'm going to leave aside. And just note there are two exceptions to the rule, and in this case, I think the exception proves the rule. One of these is for pumped hydro, which is literally just moving water uphill. And why in California we are pumped hydro experts when actually we live in a desert, when you could pump rock uphill. And the other one is lead acid batteries for cars, which we developed and really scaled up in the 50s and 60s. And the reason why it doesn't show this as well is that lead acid batteries in your car are designed to give you a lot of current for a short period of time. We haven't been doing much work on those since, because our energy systems, the electrify everything mentality needs smaller amounts of current for long periods. The battery in your phone, the battery for an energy system are ones that we've optimizing here. We have stopped investing in R&D over here. So, yes.
But pumped hydro is mature and very efficient, and it's basically at its limits, right? Once you're in energy, like you don't get Moore's law once you're down to the thermodynamic limit.
That's right. Pumped hydro is just about moving X amount of material uphill. And so the energy is equal to mass, mgh, mass times the gravity times the height. We're not optimizing on the height. That's fixed by nature. Gravitational constant, that's also fixed, and it's just the amount you move uphill. So that's why I say this is an exception that proves the rule. We shouldn't be surprised that one is not making further progress. The thing that the academics in the room should have worried about is that learning curve I showed you doesn't seem to have much role for what we do. You'll notice it's a simple one-factor curve. It's the total volume of sales and cost. And so that's very unsatisfying. We are trying to make the case, whether we have a reasonable or unreasonable administration, that research and development matters. And so one of the things that we're quite proud of in our lab is that we built the next mousetrap. Instead of the one-factor model we used the data to build a two-factor curve. And it turns out the most salient term is to add to it. So there's the one factor. And so we added another term for what's the investment in R&D. And investing in R&D is actually harder to measure. There's a grant program in one area. Is there spillover between investing in R&D and solar storage or electric vehicles? There's some crosstalk. So this is harder to measure. What we are finding among the different metrics is that one of the most useful ones, actually should please students, but maybe not their advisors, is that the number of people who start a PhD, but do not finish it, but stay in the field is a particularly good measure because it generally means that you or your advisor or friends have decided to spin out a company in this area. And so this is one of the interesting measures and one of the things that we are most proud of at Berkeley. So normally Berkeley and Stanford kind of battle for who has launched the most clean energy companies in a given year. This year, Berkeley won, last year, Stanford won, but for the past 5 years in a row, Berkeley has produced far more women and minority-led startups than any other university. And that's not by accident. That is through some intentional efforts to bring in more diverse researchers in the area. I just came back 73 hours ago from Morocco. They became a clean energy leader after a mandate from the king 15 years ago, something I worked very hard on when I was at State Department. And one of their observations was to support what at the time no longer was the largest wind farm in Africa. That is no longer the case now, it's Kenya. The largest solar field, now it is Kenya and Namibia. And the largest thermal storage facility, it may still be the biggest one. There's one in Harbin, China that may be bigger when they finish the next stage, is that they formed a new department in the schools of engineering at all the public universities in the country. It's a very top-down system. Every university is named after the king, so it's easy to keep track of them. And what they found is that by launching these new departments of energy engineering, they had the highest diversity. Their metric was women versus men. By far more women added in, whether you think it's because they gravitated to it or because it was a new area not previously occupied by men. Witness computer science in many places. But it's a really interesting process, and it's a similar thing to what Berkeley tried to invest in this area going forward. And so it has been an interesting part of the process. And it's worked. Let me just show some California data. So here is the power demand from midnight to end of the day, midnight again. And so that demand is sort of flat in the middle of the night when, you know, us old people are asleep and young people are doing whatever they're doing. And in the evening, there's a peak. And so California does get a lot of energy from solar. This little bit of orange is the amount of energy in storage. 3 years has been a massive transition. Now there is no financial support if you just install solar in California. But if you install solar and storage, there is a subsidy. And so what we're seeing now is that California now has enough solar alone to meet the average demand for power during the day. We cannot meet the demand in August and early September when we have huge ramp up in demand. We also have fires and things. But we have this interesting situation where we are adding enough storage. And if Texas builds what is in their version of the queue to build more storage, Texas will far eclipse California in terms of the amount of storage online in these different forms. Yeah.
Is California building a lot more solar fields?
Not the big ones, because the big gigawatt scale systems that you see in China, a couple were built in Nevada and in California when there was federal money to kickstart the process. Those are now gone, but we're now seeing two interesting features. California does a lot wrong. We kind of are stuck in the 2 steps ahead and then 1 step backward picture. But California is now building significant amount of solar on middle and lower middle class homes, not just the affluent first wave, the privileged energy for the privileged people. We're seeing this fairly broad build out. Now we're seeing trailer parks and all kinds of things, taking the odd bits of land in the corners and building solar. So there is an interesting process. California has lots of problems. That is not one of them right now. And if you look at what's happening in the market, it's pretty remarkable. So this is, and I've chosen the time of day very strategically. So I admit that in showing this curve. So here we have energy where batteries are charging up. This is the wholesale price of power. We're charging up when prices are low or going negative, and I'll come back to that, and discharging when the demand is high. And this is a remarkable process, so much so that the price of power is now going negative in California because of renewables. And even in the former oil and gas only world, but now quite diverse, Texas is going to zero. There's some New England problems. You guys are doing quite well here as well on the shore of the lake. So it's an interesting mix of not only the technological process, but real market transformation here. Yeah.
Can you go back to the prior slide for a second? Absolutely. So the story in the Times today, given what's happening in the world today, which you may have seen, is the question of how tariffs are going to impact this.
Yep.
And the point, for those who haven't read the article, was that storage was likely to be the most hit by this.
Absolutely.
Are you going to comment on that at some point in this talk?
Well, let me just do it now, since I said ask the questions as we go. So absolutely, that's right. China controls many of the critical materials for storage. When we think about lithium ion as the benchmarking storage, your phones are almost certainly lithium ion. But those of you who have a newer vehicle from the company I'm not going to mention, or from electric vehicle from VW, your vehicle almost certainly does not involve the most human rights and environmentally abusive material, which is cobalt. And I'll get that in 1 second. But if the US and other providers do not diversify into new materials, we will see we will see the prices rise and this really good story get thrown away. The one piece of hope I have, and that's why I showed on the storage graph, and this graph is going to come up again, so I'll just do it now, is that like solar, storage is not one technology. When the kind of storage revolution started and the national lead for this, the national labs is Argonne Lab, that's where the storage hub is. There are multiple storage chemistries. And that's the strongest positive part of the story. I think the slide's coming up, but I'll just say the answer because I'm not sure when it pops up. And that is the process to get rid of cobalt in batteries, meaning not lithium ion, it was a switch to lithium phosphate. Slightly worse performance, far cheaper material. VW and the T company both adopted that in large scale. For economic reasons, I don't think either one was being driven by the human rights and environmental abuses in the Congo as a result, but it is a remarkable version, and we wouldn't get it without the diversity. Whether companies are going to invest, so under the IRA, there was money and we were seeing re-onshoring of solar manufacturing and batteries, whether that goes on or not in this new onslaught against higher education, against research. We will find out. And so it is exceedingly vulnerable, but we have learned how to diversify in the storage world. So I think there is a good message if we act on it. And if the US really wants to be the global provider, then we need these alternate technologies. Our team does a fair amount of work to try to analyze the options. Only because one of our students became the chief sustainability officer for Lyft, we were able to get them to commit to no Lyft vehicles would have, that they would all be electric by 2030. Of course, it's ironic they don't acknowledge them as employees. We're leaving that for the labor people in the room. And the other justice feature, which is just crippling, is that in places with high cost of living, we have the situation where you have to drive till you qualify, right? So the poorer you are, the further you have to drive, the less time you spend at home with children. And so housing policy is climate policy in another guise. And California, and now the Netherlands, and we hope soon Massachusetts, each have an explicit piece of their climate law that reflects that issue. So in California, we have a cap and trade program that generates about $12 billion a year. And the law is written that 35% as a floor, not a ceiling, of that money must go to underserved, marginalized, and fence line communities. And so there is actual fund to invest in that. And that's why when you drive around California, you now consistently see solar on the rooftops of housing developments. Low income, we used to call them projects. We thankfully don't call them that anymore. But we are seeing a direct feedback. That does not mean we're bringing down the price of housing. In fact, the more we emphasize, the .com world, the more we make it that you have to drive even further. So really challenging piece. But we have learned how to do these right if we choose to do so. Number of jobs in California, we're now about 2.4 million electric vehicles. So right now, the UK and California are kind of running neck and neck with each other for second place behind China, which is at 26 million electric vehicles. So interesting mix. Other part of the story is another one where how we interact with these sustainable development goals, I think, is a critical piece of the story. And this is one where the language on the physics side and the language on the economic side do not line up. And so this is something which we're seeing around the world. It was made famous in California It's called a duck curve, and I use this one because the author decided he's drawn a plesiosaur, a dinosaur, I guess, in the shape of a duck. So the idea of the duck curve, I'm just curious, who in the room interacts with kind of duck curve analysis on a semi-regular basis? Oh, no. Okay, a couple, all right. So the idea of the duck curve is the curve I showed you before, power demand from midnight to midnight, 24-hour cycle. It's roughly flat in the middle of the night. And as in California, we added more and more solar, we hollowed out and made the back of the duck. So our net demand goes down, the more distributed solar. In my own home in Oakland, we have 6 kilowatts of solar on the roof. We have a stationary battery in the garage. And then we have 2 electric vehicles, neither of which are allowed to sell power back, even though the battery in those electric vehicles is 5 times bigger than what I have stationary in the back. And that is a ridiculous failing. We should be requiring every single EV must be not vehicle to grid ready, but doing it today. And we don't do that. And so we don't push on the companies nor the utilities. Yeah.
What's your electric bill?
My electric bill, I do not have a grow room, but I have something else, which is a big energy. I have a hot tub. As Michael knows, I make most of my phone calls from my hot tub. So our electric bill is about $50 a month, but it should be negative if I didn't spend so much time soaking in it. And so this picture highlights the real mismatch in the physical science and economic story. Almost every utility executive is fearful to death about this curve. I regard this as the biggest success story. 2023, California, 4th or 5th biggest economy in the world, depending what Germany's balance of payments that month is relative to what they're investing in now new defense for Ukraine. So let's just call us the 5th biggest. We are now exporting power, and California has now exported clean energy for as little as 15 minutes, but as long as 6 hours for the last 113 straight days. Now, we do a lot wrong, but that is a remarkable win. And so my economist friends say, oh, this is horrific. You have now driven the value of new clean energy on the grid to 0. So we're not going to install anymore. And as a physicist, I say, this is the point, right? This is what we're supposed to do. So we need some mechanism to communicate. And that's why I showed you that market graph a second ago. So versions of what one can do is if all of our vehicles were vehicle to grid, so we could sell power back, and after your home, generally your next largest purchase in life is your car, and you use your car an average of an hour a day. That's a remarkably stable number worldwide. So if your car is sitting around for 23 hours a day, someone needs to Airbnb your vehicle so that you're using it for something else. And since my house is typical, each of my electric vehicles, the battery in that car is 5 or 6 times as big as that stationary battery that I bought. I should be using it with a very simple app that says when the price of power on the market goes above a certain amount, or when the green premium is high enough, whatever it might be, that stop doing this or that in the home, turn off my refrigerator for a bit and sell power back into the market. But we don't do that because currently the biggest US EV manufacturer has resisted making them two-way. Leave that aside. But it costs around $14 for the circuit to put in your car. I guarantee you will not see that in a price issue. And we know that because if you bought a laptop or a cell phone in California, each cell phone has a tax built into the price. It's $19 per cell phone, so that the materials are recycled with a big footnote, and it's about $29 per laptop, and the sales are unaffected. So we could be doing this relatively easily. And the other version is if you're a hydrogen proponent, now you have a source of green energy that you could be using to make green hydrogen, as opposed to the natural gas hydrogen or hydrogen plus carbon capture. So all of these are interesting opportunities to really build out a different picture of this energy landscape. I'll do one more example and I'm going to jump ahead because I have, as is typical, gone on longer than I said I would in a couple different ways. So one of these areas where we are at the very early stage of learning. Europe and China have moved ahead aggressively with offshore wind. There's a whole bunch of benefits. It looked more expensive than onshore wind even 5 years ago. Now that's not the case. Here is a KTH, the Royal Institute of Technology in Stockholm, Norway, Portugal collaboration that says if you're going to put offshore wind in place, why not also put very nice little buoys, and you can actually generate more power with a sea of these buoys than from the wind turbines. And so this company called Core Power is a leader, but not the only company doing this. You have a buoy, it's about 8 meters tall, and you basically have a weight inside it and you generate power as you go. And now you're dual using that infrastructure offshore to bring the power in. You send this energy in as well. Turns out these are wonderfully modular. They're much easier in some areas to put in than wind turbines. So it's an example of an innovation where we should be thinking much more on this systems level. Last, I lied. I'm going to do one more super quick before I jump to the Health Africa one. And that is 10 years ago, we were asked to go visit the government of New York. The mayor invited us in to say, well, I'm really thinking about what we do on this EV basis. And so what we did was we took all the data for all the taxis in New York City, and we said, what if we just model this all with a cellular with an agent-based model? So each red dot is a taxi with a passenger in it. Each blue dot is a taxi looking for a ride. And taxi drivers tend to be low income and immigrant in many communities, largely so. So they typically will reside in New York City in Upper Manhattan. So what you're going to see is the taxis running around, and the green circles are going to be where you want charging for those vehicles. So let me just run it from midnight to 3 in the afternoon. I'll run it twice just because I like this little video a lot. So you can almost see New York City. You can almost see Central Park. Here are taxi drivers charging while they're in theory asleep, or some of them are asleep. 4 in the morning, wait till you see the flood of blue. They come down to Manhattan, but now they don't want to drive home. They want to charge up in midtown areas. And so as rush hour ends, you're now going to see green charging circles appearing all over. And just because I like this little video, I'm going to show it again. And so we learned a lot. Again, you can see Central Park a little more clearly, kind of an interesting picture of where infrastructure should go. We did this analysis, and the mayor said, well, that was great. I commissioned you to do it, but taxi lobby is too complicated for me. Forget it. So I was very dejected. My student from Chengdu said, don't fear. Let's go meet the mayor in Chengdu. And so my student, Bo Li, and a group of us worked on the analysis for EVs in China. And we went to Chengdu, and they said, well, we like to be the second fastest. The city that wants to be the first fastest is Shenzhen. Go to them first, we'll learn from them. And so we did, and Shenzhen is, of course, home for the company that just eclipsed Tesla 2 days ago, BYD, Build Your Dreams. And so hometown company, they may have a gender problem of taxi drivers. This is the drivers receiving their BYD vehicles. There's an interesting question of where did the old gas-powered taxis go? Don't ask, it's Southeast Asia. But they got their taxis, and the etiquette in China is you drive a 12-hour shift, and you give the car to the next driver full of petrol or charged. So of course they did this, and the first minute they experienced the problem, and we gathered the data on the queues at the charging stations went on for hours. The taxi drivers were furious. If you look really closely, you can see one empty bay. This was at the time the largest EV charging station in the world at the Shenzhen Central train station. And so I was going to write a paper, and one of my students said, we don't write papers anymore, Dan. What we do is we take the data. This is the larger, darker circles are how long the wait times at the central train station in Shenzhen. We take the data, we don't write a paper, we build an app. So we built an app modeled exactly after United Airlines frequent flyer miles. And that is, you get points for showing up exactly when you schedule to charge. If you're late, you get docked points. And we used it, 20% immediate drop in wait time, about 35% improvement in revenues. And this app was very, very popular. We won an award in China for doing it. And now the city of Chengdu, that says we do things second after Shenzhen. Now we've been asked to integrate in subway ridership, buses, taxis, and e-vehicles. And so there's a heat map of the waiting times. And that was actually the inspiration for why I came here last year remotely to talk, because we use this data in the design of this Oakland Eco-Block project that was mentioned last time. Yeah.
Just a quick question.
Yeah.
Have you considered using this, or have you done it in the heavy duty delivery or trucking space?
Great question. We have not, because China is involved in an internal debate about whether they should be doing batteries for long distance heavy trucking or hydrogen. And so we are waiting essentially for them to decide which of the route modes they would go. And hydrogen production in China is something outside of what we've worked on, but we've asked many times. And it's fascinating because you could do a lot with that. And because those big trucks tend to run very regular routes, they have large power demands, they could be a great distributed battery system. We're primed to do it. My former student, Bo Lee, who's now a professor at Fudan University, is the lead on that. And we're waiting for that decision to come down.
I used to be in that industry and it just
I think it's right for,
fits.
yeah.
Yeah,
Yeah,
perfect.
I am keen to do it, but we haven't done it yet because they haven't made the choice. Yeah.
From an emissions point of view, which one do you think would be better for the Chinese trucking industry because of hydrogen in China is
Correct. And a lot of the electricity for EVs is also from that. Chengdu and Shenzhen are actually powered by another controversial project, but it's now, I guess, Michael, we need the kind of historic perspective on this, right? A controversial project in the past, so a lot of their energy comes from Three Gorges Dam. That was very controversial, but now we've decided that's settled. And now, of course, Africa for 40 years is now at a potential jumping in point on the Grand Inga project. And their idea is to be sending power to South Africa, close, 1,500 kilometers, and 4,000 kilometers to Europe. And so they are looking at the Three Gorges Dam model, and the Grand Inga would be 3 times larger than Three Gorges. So wait and see. Yeah.
Yeah, I'm just thinking a little bit about the contrast between
Yeah.
the China case and the New York City case that you just presented to us, and trying to understand what went wrong in New York. And you showed us your great visualization with the green dots representing the optimal charging locations, and yet that you said there's opposition from the taxi drivers, which suggests that you and they have different notions of optimal. So what was going on there? Like, why was this receiving so much opposition in New York?
Yep. So the opposition came from 2 things. One directly related to what we're talking about, and one unrelated. And the other one, that was 10 years ago we did that. And it was the rise of Uber and Lyft. And taxi drivers didn't want to do anything that risked the process of getting medals, getting taxi licenses. And so there was a big pushback there. The second piece was that what we were coming up with was you needed to distribute the EV charging access where drivers were. People who live on 167th Street, 180th are not going to want to have their car 5 blocks away and go get it. And so there was a effort, the city wanted to have centralized charging. So drivers would come back and they would all be in a central bay. Drivers did not want that. And so that's where it stalled out. That was not an issue in China. And so
It was not an issue in China because the government had more authority.
because they had more authority and they listened to this feature that taxi drivers, they basically, because people live in apartments there, you could have 20 charging spots at an apartment. It was quite easy to do, as opposed to what was going to look like it was needed in the Bronx in particular, was much more distributed. And so it didn't really, it may do the 2. Yeah, it's right here.
I just sort of relate issues in terms of what Con Ed could do in New York, or also in terms of the grid.
So now New York City has become a hub of distributed energy storage. They have some really impressive programs, but they did not have those back then. So if they took a second bite of the apple, pun intended, they could do a version of that now. That wasn't the case at the time.
Many real estate developers nationwide included both a charging station and solar panels on the roof of the house?
Thank you for asking, yes. So the University of Colorado Boulder set up a competition to do this, and in Boulder, there's now 3 companies, one of which is now operating in the Bay Area. And because one of them was founded by a student at CU Boulder from Hong Kong, there's now a version of that company in Hong Kong as well. The French have had this for quite a while. There are now solar trees in France, solar awnings over battery stations, and you drive up and plug in your EV there, and they also sell power in the neighborhood. And that brings me to this last point with the, as I mentioned, we talked about the Oakland Eco Block before. This project had a 7-year gestation from the first grant from the state, the California Energy Commission, to actually building it now. And the question we wanted to answer with the Eco Block that we talked about a lot last time was, we do so much that is environmentally perhaps good, but is clearly socially regressive, right? The subsidies, the benefits for doing EVs and solar home systems are all available to those who own property, who have driveways, and why can't we get away from that? And it's not just the fact that the rich have a far bigger voice, it's that we think about individual property. So the Eco Block is designed to be solarizing a block, solar on all these rooftops, an apartment building, a crack house. They agreed to be part of the process, and you'll see some mother-in-law units in the back. And so all that solar gets generated on a rooftop, and then it gets put in a battery and redistributed back to the household. So it's a collective. The community forms an HOA. This person who lives here owned the garage, donated it to the job. The batteries are going in here, and the power then goes back to the households. And they took 2 years to decide how much power do you get back. Is it based on just each property gets equal amount, number of people in the homes, square footage, whatever? So they came up with their own solution. Doing that, 2 other things happen at the same time. One is the power goes back, excess power gets sold to the utility, which took another 2 years to get done. But also they decided that by doing this, they wanted to have EV charging on the road, not on driveway for people who don't own property, and to have zip cars as part of the package. So you don't have to be an EV owner to have access on the block, you access it with your app. And this was an accidental design because we picked something with 2, it's a block and the streets on either side. The community voted and the city accepted to turn these 2-way streets into 2 one-way streets, and to go from 2 lanes to 1, and to make a park on the other side. And it's a green park with a perforated non-asphalt base. And so now there are these linear parks that are going in on each street. And that was also complex in the process. I know I've gone over time. I'm going to do a 2-minute version. Sure, okay. I'm going to skip a bunch of interesting details and highlight something which is currently a casualty of the death of USAID, but may have a path out. So when I was at USAID in 2021, 22, and then went back to my academic life, in a very kind way, Samantha Power, the head of USAID, said, you can take one program with you, which I've never actually heard someone say before. So I reached into the hat and pulled out one program, and that was this one. And so the idea of HEDA is to take advantage of everything we've said and to actually put services first. So this is energy in the service of health, not what I've really described so far, which is kind of energy in the service of clean energy, but hopefully some social benefits. So this website is now mirrored on one of those Save USAID sites. It's no longer there. The simpler name is Powering Health. And the goal of this project was to recognize that if we look at a map of Africa, the grid is in black. And some people think these dots are green. Some people think they're blue. I think they're blue-green, but you guys pick. Each of these dots is a health clinic, from a tiny little dispensary to a tertiary big hospital. There's about 170,000 health clinics on the continent. My own lab is focused in South Sudan, in Eastern DRC, and in Kenya. There's about 10,000 health facilities in Kenya. And so the goal was powering these facilities in a energy sustainable, economically sustainable, and staff-wise sustainable way. So one of the terms I had never heard before I got to USAID was a GDA. It's not a government program, that's a global development alliance. I didn't know that. So a GDA in this case was a commitment by a whole bunch of partners to fund the capital needed to do this if the governments came up with a plan to fund the OpEx. And so these were the initial partners, a couple government agencies, the UN agencies you'd expect, my lab at Berkeley, now moving to Hopkins, Arizona State's Michael Crow started lab, and some cell phone companies, some power companies, Caterpillar's on here somewhere, I can't seem to spot them. There were big letters. And so these consortiums formed a GDA. We think the price tag is about $5 billion. We actually raised about $2.5 billion until one of the foundations just recently pulled out due to pressure from a certain US president. And so of the 54 African countries, so far 11 have signed up, meaning that they have worked out internally, each country differently, how the OpEx will be covered if the CapEx is provided. What our labs do is to build digital systems so that we have real-time data, and providers only get paid 3 months after the effect, after the pay period, if we have validated that the cold chain and the refrigerators and the baby warmers and the oxygen generators worked as expected. You get paid a discounted amount if your downtime due to operation and maintenance limited that production. And so our goal for the end of 2025 is 10,000 facilities. That's a goal we're going to meet. And the ultimate goal, when I'm 100 and whatever, is 100,000 facilities. Nigeria, the DRC, Tanzania, Eswatini, Sierra Leone, Senegal now, Kenya is or was about to sign, are all countries that have signed up to be part of this process. And it's a design process around these mini grids. Some are systems that are larger, some are mini grids in a box. So the solar panels come in the box then becomes the clinic, the storage rooms, et cetera. And they're bigger facilities, and there's a real emphasis on building in IT. Almost every African country now has a program to go to EMR, electronic medical records. So they need this for other reasons. And one of the features that we have seen at many health clinics that get hardware donations, but not an ongoing investment, is that the healthcare workers work there for a while with new equipment and then go to South Africa or to Europe for jobs. And so sustainability in terms of staff has been a big part of the story. And it's pretty dramatic. This is, as the best of my knowledge, the largest mini grid in Africa today. There may be a bigger one at a mining facility in a country I won't mention. Libya. And what happened here, this is in not a city you think of as a clean energy leader. This is Goma, currently under M23 control, and lava may be spilling into the city next week. So this was the original 0.5 megawatt array. This is not an abandoned building. That is the hospital here. And so what was put in was this 0.5 megawatt of solar energy storage, and it was replacing an old diesel generator of which the voltage was going through these massive, almost 100% fluctuations. Guess what? Oxygen generators get shorted out instantly when you do that. So the lifetime of equipment was in the toilet. We installed the system, and the power quality went from this to this. It was so successful that 2 DRC-based companies were launched as a result, and it went from 0.5 megawatt, and it's almost done. There's going to build a little more here, but it's at about 4.4 megawatts, going to 5.5 megawatts of solar in a city that no one thinks of as a leader in kind of clean energy installation. It was then so popular that the Energy Regulatory Commission of the Congo went and raised $75 million on the European markets to expand this process, because pharmaceutical companies and the companies I showed you before on the installation side all wanted to be part of it. here we have an example of our voltage and frequency plug-in device. It's a Berkeley spin-out. You just plug it into an outlet. The new version has an outlet to replace the outlet you lose, because here outlets are not in scarce supply, but they are there. You scan the QR code and it reports voltage and frequency data real time. That's how companies get paid in this process. And so kind of there we are as an example of pulling these together. Yes.
Was it hard to find land in the middle of an urban area or?
It actually wasn't. So what was here before was a series of small housing and store units here. And so they've actually moved to the other side. This is in a big urban area, 1 million people population. It was not difficult here, smaller areas. But that varies. In Rwanda, that would be hard. Highest density on the continent by far. So yeah, it's not a uniform story of any. So I would argue, and something like come to you in 1 second. So I would say we have ample tools on the hardware side. We need to partner them much more directly. Of course, there's no simple fix, but what we are really missing is kind of the ability to put this together. And I'm always reminded by what Kurt Vonnegut said. And this is, to me, this is the worry. So thank you, and let me give you the first question.
Yeah, I guess I was like wondering who was typically hired to serve as like on-site technicians for these solar farms.
So it's a great question. So the countries that signed up first were the ones that already had pretty active mini grid developers. So Kenya and DRC and Rwanda and Uganda and Senegal and Sierra Leone all have pretty active industries with more than 5 and sometimes more than 10 different mini grid providers. Powergen and Zola, a variety of companies. And so they went first. And so we did take advantage of the coalition of the willing. In South Sudan, which is not an easy place to work by any means, there is a South Sudanese company, but they've actually contracted with some dispute with 2 Ugandan companies. And so they'd like to make it indigenous. They have not yet. So it's a great question. And I think that is one of these rate limiting steps on when does the government decide there is enough capacity so they want to buy into this model. And now, of course, they say, I don't want to buy in at all because you just closed USAID that was the coordinator of this. And so not so good. Thank you. You guys have been super patient. Let's just jump. Yeah.
I just had a quick question. Given the political backdrop in the US and the dislocation it's having in terms of both the research and projects, who do you think benefits from this?
China.
And are there any other countries that you see kind of taking advantage of the opportunity outside of China, and how big of an opportunity do you?
Great questions. I think the honest answer is I don't know.
Yeah, it's.
I wish there was more. I want other countries to step in because I think the opportunity based on the cost numbers, based on the value of meeting these different targets is really high. China has been a large investment partner, but largely only in the big projects. And it's hard, there are not many mini grid companies that are Chinese that are active here, but I would love to see more. So you can make an argument that India has now developed some real impressive capacity in this area. There is a solar for-profit company in India run by someone named Harish Hande that has about 200,000 employees in India. They have now decided to partner in Nigeria, but they're just starting. And so it's a great, great question. I'd like to see more filling in to kind of fill the need, but also show the US stepping out of this is just foolish, right? You're giving up on all kinds of interesting business opportunities, whether you care about people or not. Right?
And sorry, do you think it's a beneficiary for the EU, or whether they would kind of get aggressive?
Really good question. There are a couple active Italian and German mini grid providers, one of which I highlighted their hardware. That health clinic in a box is actually a Italian US company called Off Grid Box. And there are a couple, there are not a lot. And largely because the demand to do these projects in Europe right now is fairly high. And so they don't really need the African market as much. There are some very active Spanish and French companies in Morocco, which has this long-term history. More of the mini grid companies in Kenya are actually US spin-out companies. So Yeah, that's a good question. I don't know the answer to that.
Lots of reference to what's going on in China, Europe. South America seems to be missing in this. What's going on in South America?
Yeah, so Mexico has become a really big leader in this off-grid space. Their Ministry of Energy, SENER, is very active. We actually just had a meeting at the World Bank two days ago, where their lead grid modeler, who's now moved to the Inter-American Development Bank, Marcelino Madrigal, has a mandate to build out more of this. Except for the Amazon, there aren't large swaths of Latin America where electricity access at all is off the chart. There are some, but it's not like the case in Africa or Southeast Asia. A lot of energy in Latin America from hydropower and some from gas. And the most hilarious example is that any Argentinians or Chileans in the room? So there's no love lost there. Chile owns fossil gas plants in Argentina that only supply Chile. And so there are some really quirky relationships. President Bachelet has been a real leader in doing some of the projects here, but not at the scale. And actually, when you look at the number of off-grid people, it's not large in number, but some of the most threatened areas of the Amazon could really critically use this. COP30 will be in Belém. There will be a focus on this, but in terms of numbers, it's not very large. So interesting.
A bit more of a meta question. I study computer science and public policy and was just curious if you have reflections or learning of thinking about working on policy and programs on like highly technical fields and how you think about the intersection and going forward as things become more, AI driven or technical.
Well, so, I mean, one of the natural starting points is the whole data center question, right? And I don't want to say the extreme version, although I do think it, that it's not clear to me that the data center problem is going to be this crippling thing. It's the largest growing demand of energy, but for properly designed data centers, you can actually run them on renewables. We're not now because few countries are pushing for that, but you could do so because so data centers, while they need continuous computing capacity, actually the demand can be tailored in a way where you would modulate it. And so data centers plus storage is a really interesting model. And it's not quite as extreme. The reason we picked health clinics wasn't just to do health services. It's that health clinics are wonderful anchor customers. When the operating room is on, when the AC is on, they have a huge power demand, but it drops dramatically when they're not doing surgeries. And so if you build for the peak, then you have all of this kind of what I would call Airbnb space that you could fill in. Data centers could do that. There are a couple of people thinking about this. There's one very active group that wants to put data centers in the stratosphere because wind turbines that are tethered in the stratosphere generate wind power. The capacity factor is almost 100%. And so floating data centers is an actual Silicon Valley topic. But the next thing that I think is more likely is that we now have the first companies that are licensing for space-based solar to beam the power down with microwaves. And cities are a great demand, but so are data centers. And we have contracts, and it's because of the fall in price to launch. And it's not just rocket launches. We now have the first company that's doing spin launch. And so you take the payload, you spin it around, and you send it up, and you get into low orbit, and then you have it drag to where you want it. So there are interesting opportunities for data centers to be on the lead. So that's one version of the process. The other one, I glossed over it a bit, but all of this focus on doing all this hardware effort and not making it another white elephant is all about this real-time feedback of data. When we see a refrigerator going down in Malakal, South Sudan, we now know in 5 minutes that this freezer is going to go out of range, and the companies are all agreed to this service contract where they have to provide it. So that's a data question. There's a downside to that. The downside is that what are the companies that can afford to only get paid 90 days after we've proven the power? It's not the small companies. It's not the indigenous companies. It's the big ones. It's the GSMAs, Orange, and others who can carry it on their balance sheet. So what we need to do is to get enough of the big companies involved so that we maybe have a revolving credit scheme or something else where we can then address the questions and actually help support smaller companies. And I'm worried about that if we don't build that in early, and that's why cutting out the USAID. So that's not a full answer to what the AI data science, but I do think it's a place where there's a lot of opportunity here. So really.
Racializing empathy, where did you hear that?
Well, Elon Musk said empathy is actually a huge failing of humanity. Right? So he said empathy is bad, right? He said that 2 weeks ago, right? So I actually think operational empathy is what this was designed to be about, and yeah.
I asked you about a year ago at the Housing and Climate Change Conference, your views of geoengineering, given University of Chicago's investment in that area.
Yeah.
And feel free to just completely evade the question, but.
I want to be.
Okay, I wondered, well, first I'd love to hear again your views on that, because I agreed with them, but also, do you think anything's gone, what's happened in the last year to make you change your mind, or are things getting better? Does it look better? What's the landscape?
Well, I mean, obviously you should ask David Keith across campus. Our views couldn't be more different on this. I would say the language of the geoengineers has gotten more subtle. I would not say the message has gotten more subtle. I am all for research on these topics. As you saw in that graph, we are going to need to go carbon negative. So I am all for doing research on it, but I do not think that should be our primary, and this is where I think the language of the geoengineers, maybe not their funding, has gotten more sophisticated. We have all of these opportunities to deploy clean energy now, and if you really want to have the private sector take a lead, you need to build this out so they see the business case. So in my view, geoengineering is something that we may need mid-century. And it is exactly in the category, let's learn more, let them do research. But I view a huge amount of the attention and interest in trying to find a technical fix to a social problem, as opposed to starting with the social problem. And then if things get worse, and they probably will, I think we will do this, geoengineering, but I sure feel that we are jumping over the social part of the solution. And I know that's not so popular on part of this campus, not so popular with some of my friends at Berkeley. But I feel like we have, this argument that solar and others have become cheap. Well, why are we not only installing these technologies? It's because the total amount we invest in clean energy today is a fraction of what we subsidize, not the CapEx, but it's a fraction of what we subsidize fossil fuels with today. And that is making this fight absolutely, unfair is the wrong word because markets don't have to be fair, right? But the jump to geoengineering right now, when we are actually at a point where these are not only cost effective, but they actually produce much more robust job gains. I think it is a mistake to be pushing as hard as we are on the doing side. I'm all for the research part. I am not for the deployment part of geoengineering at this point.
What part would you say that, how would you suggest that activists and members of communities best approach supporting sustainable energy projects?
So, great question. And there's no 1 minute, 2 minute answer to that. Every time there's a new administration, whether it is forward looking or whatever this one is, everyone says, well, we need to really make the case harder for why we should be part of the equation. And so this is not just given who won this election. But I do think that one of the stories that the energy technology crowd does not know how to do well is to really highlight the cost and the other benefit story. The reason why I kind of gave this version of the talk here is because what I think we are leaving out is not just what's the raw cost of solar plus storage versus fossil fuels, but what is the cost of meeting these social goals? And social goals are not, liberal agenda language. These are the things we actually want, right? No one goes home at night and says, oh, it was a great day. I consumed 19.2 kilowatt hours. I feel so good. They say, I got where I wanted to be, or I had better healthcare service or whatever else. And I think we have forgotten or failed or never even started to say that bigger story. And that's, I think, where activists come in, right? Because highlighting not just the need in impoverished, marginalized communities, but the huge benefit to the state overall by actually giving them reasonable services. I don't think that's any kind of welfare giveaway or some safety net, although I like safety nets. I think that we are not valuing this big part of the story. And because you said it, I'm gonna have to show it, and it's certainly not popular with this administration, but way down in the slides I'm not showing would be, here we go. So this is the price of new energy projects today. This is not a Berkeley or California centric map. I'm using the one built by University of Texas, right? Therefore, honest broker. Maybe not. But this is the minimum cost of energy today. They don't use the color scheme I would like. Wind is in green, and solar is in this mauve color, and fossil gas is here. The nuclear story is kind of complicated because they're not taking in disposal costs. So you can like that or not like that, but leaving the nuclear story aside, this is with no price of carbon.
Excuse me, doesn't Texas have its own energy problems as it is?
They do indeed, yes. And so I just labeled them here. This is at no price of carbon. California's price when I made this graph was $20 a ton. Now it's actually 30. And you can see if this doesn't cause epilepsy in anybody. You can see that basically what happens is solar expands at the expense of gas. And if you go to $50 a ton, which was the estimated social cost of carbon a year and a half ago, this is the US map at 50. The current estimate for the social cost of carbon, reflecting both impact on marginalized communities and on ecosystems, is actually somewhere around $170 a ton for the huge margin. And that means that you would do nothing except for clean energy projects in the US. That's actually what former President Biden said in the social cost of carbon executive order that he signed on day one. And it became an interesting case. It went to a conservative judge in Louisiana for interesting reasons. It was blocked for a year and then it was opened up. But by that point, the momentum on actually using it as they wanted to require all federal contracts was lost. So it's an interesting case. Yeah.
Yeah, so a lot of our conversation about policy is focused at the federal level thus far, and as you alluded to, and seems clear, federal support for clean energy or science in general seems non-existent for the next few years. What are your thoughts about what can be done at the subnational level? In particular, what would you say to a mayor, who came to you and said, hey, what can we be doing in our city right now?
Okay, so we have an expert in the room on that, but I'm going to pass around for those who want to stay part of my answer. So this is the newsletter of the college I'm in at Berkeley, and this issue is devoted all to engaging and hiring faculty who work on justice. And Berkeley's own internal experiment was to hire one faculty a few years ago who worked on justice issues as her primary, and then we leveraged that to then organize a cluster hire of faculty who worked on justice, and these are really quite applied researchers. This group of faculty was then hired, and then other departments who were not part of that process said, well, we want to be part of that. And the university said, well, we've already done our cluster hire. And all of these were then hired by other departments and schools that wanted to leverage in. And almost every single one of them, we have one exception, almost everyone is working very closely with a local municipal office, be it the mayor of a city or we have some regional experts who work on adaptation in Ecuador and in Peru, but each one of these hires leveraged work with community as the center of what they do, not as the outgrowth of what they do. And the lessons are pretty striking, that the capacity in city offices almost always needs to be increased, and having trusted academic partners is a big plus in moving forward everything from new housing policies to this thing I highlighted about electric vehicles should all be vehicle to grid enabled. And so I would argue one of the things that cities should do is actually to find those nexus points on their academic side, because everything I've described is changing fast enough that unless your city is one of the big investors, Boulder and Portland and a number of others, it is difficult to do this, even if you have really high quality NGOs, community associations. So I think one of the areas is this kind of partnership model. Works for the universities, I think it works for cities well to do that. So that's one piece of that story.
I certainly respect your being able to turn your advice to a mayor into hiring faculty. I admire that, but I guess what I mean is, what are the levers that cities have at their disposal, given that they should not be expecting support for the federal government in the short run? Like, what's a policy thing cities
So,
can be doing?
Yeah, so I think there's a fairly long list. One of them almost certainly, and tried out in a few places, is to make the process of permitting one that invests in community-based energy. So we have a number of cities that have now said green projects jump to the top of the queue. Now, if you do it in a way that only rewards solar on rich homes in Hyde Park and Piedmont, California, you are perverting the idea of this. But we've seen now a couple places, Troy, New York has done it. We've seen it in San Jose, where permitting goes first to the green projects. And what they've tried to do is do green projects at scale. So like the eco-block type of project, and the version that we talked about it very briefly before, but our version moved very slowly. Now Denmark and Sweden, and now it looks like Finland, not the poorest places on the planet, are all taking their version of the model. They have a better name for it than eco-block. They call it energy societies. And so permitting peer-to-peer sales of clean energy is one of the places where cities can take the lead. There's the other one, as evidenced by the data here, is this EV transition. Can be done just to benefit rich homeowners who buy an EV, or it can be done to try to put it into more public use. So that's two places right off to do so, where cities have to be the lead mechanism. And neither academics nor the federal government, even under the IRA mandates, can actually make the lead on that. So those are two places right off.
We have one question online.
Sure.
From Jan Bodart. They're asking, Ohio has recently legislated and the governor signed a law defining nuclear power as clean.
We have an hour. So interesting. Okay. So as a professor of nuclear engineering, let me highlight that with, so Jan can't see the graph, I suspect the figure.
They can.
Oh, they can, okay, great. So, complicated story, right? Leaving aside the waste management question, which is absolutely something you cannot leave aside. One of the issues that has evolved is that nuclear power is one of the technologies. This is the price curve for nuclear in the US, price curve for nuclear in France. We'll come to the China data in a second. Nuclear has not followed the learning curve that I just highlighted. And we know why. Big, complex, somewhat unique facilities do not do not see that same learning, that scaling, learning by doing. The more unique your project is, nuclear power plants, aircraft carriers, individual bridges do not exhibit that learning curve. And so the challenge for nuclear is that the competitors, renewables and storage, do follow the learning curve. So no matter what you think about nuclear waste and risk, for nuclear to play well with renewables is a complicated story. Nuclear power plants are not load following. Okay, so on a technical basis, nuclear power plants do not like to ramp up and down. There's a really great researcher, Jesse Jenkins at Princeton, who is looking at how can you do a little bit of ramping. They can't do a lot. You start to ramp nuclear power plants up and down, you stress exactly the parts that cause accidents. That is not good. Maybe the world of small modular nuclear reactors will fix that. They are interested in small modular nukes because you build more of them, so you learn more. The data, however, shows that in the US and France, two nuclear leaders, the prices have risen The only place where prices have fallen is China. This is a paper that's not yet published. You're not allowed to cite it yet. But we did a very detailed analysis across a range of plants. And one of the interesting features, and this is the newest data, is that what we're finding is that the domestic content is a critical metric. What we're finding is more than kind of 75% domestic content in reactor designs gets you a process where there is more learning. Now, there's a lot of ifs and complex features in that picture, but the basic story for nuclear fission is not good. There's 420 nuclear power plants in the world today. Every single one of them must be closed, even with the most optimistic life extension arguments by 2050, 2055. Replacing those 420 plants, there is no one that has a plan for that. Small modular people think they might get there, but the first two small modular plants, the price before they've even built a plant has already doubled. Utah canceled the first one. The other one is going in at Idaho National Lab, so kind of in a toy environment. And that first plant will not go online until 2029, which means first real data early 2030s. I would say that unless there's a huge breakthrough, nuclear fission is too late for the party on the climate story. I think there will be some people who get rich, but I don't think it's going to be a part of the solution space. However, there's another piece of the story, and that is that I actually think in 2070, long gone, the world will be 70% powered by nuclear fusion. But half of that will be 93 million. Right. So I think 2070 will have about 35% of our demand met by nuclear fusion plants, US and probably, in the world, and probably on the moon and elsewhere, and half of it will be solar, which is nuclear fusion too. So that's a really short answer to a long, complex nuclear question.
Thank you, Dan. I'm gonna call a timeout for the moment. First of all, let's thank Dan. We have